So now we can start the topic for solving the second order homogeneous second order ordinary differential equation. So we start from the case of homogeneous second order ordinary differential equations with constant coefficients. So this type of equation will be like this. So it will be a constant coefficient a with y prime, y double prime plus b y prime plus c y is equal to 0. So normally for these kinds of equations we can assume the solution to consist of exponential functions. So we assume that we have an exponential function e power lambda. Okay, so one of the exponential function is e power lambda x. Okay, so instead of y1, we assume generally that for y the solution is e power lambda x. Okay, and then if we apply this concept, then y prime will be equal to lambda e power lambda x, and y double prime will be equal to lambda square e power lambda x. So if we input these values over here, so then it will be, you will have a lambda square e power lambda x plus b lambda e power lambda x and plus c e power lambda x is equal to 0. So from lambda x is common from this equation, so therefore we get an equation a lambda square plus b lambda plus c is equal to 0. And then we know that this is a quadratic equation in lambda, and then we know the formula for the quadratic equation. So the value of lambda will be equal to given by the quadratic equation minus b plus minus under square root b square minus 4ac over 2a. So we will get two values of lambda, lambda 1 and lambda 2. So accordingly we will have then two solutions of this equation. Okay, so let's take let's do one example. So find the solution of this equation y double prime minus y is equal to 0. So this is a homogeneous equation, second order linear homogeneous equation. So for this differential equation, the corresponding equation in lambda, so which we call as the characteristic equation, will be for corresponding to y prime, y double prime, it will be lambda square, and the corresponding to y it will be lambda. So lambda square minus lambda will be for corresponding to y prime. So for y it will be just that coefficient, which is minus 1. So now we have this equation. So this equation is easily factorized into lambda minus 1 into lambda plus 1. So we now have two values of lambda. Lambda is equal to 1 and lambda is equal to minus 1. So correspondingly then we have two distinct equation solutions. So the general solution is c1 e power lambda x plus c2 e power lambda x. Okay, sorry, lambda 1x lambda 2x. Okay, so So we can take lambda 1 is, this is lambda 2. So the general solution will be the C1 is a arbitrary constant, e power lambda x, it is x, plus C2 e power minus lambda, so minus 1x. So this would be the solution. So let's take another example. Uh, 2y double prime minus 5y prime minus 3y is equal to 0. So this equation can be also factorized. So 2y double prime, so because it is 3 times 2 is minus 6, so I can write it like minus 6y prime plus y prime minus 3y. So you can take 2y, 2 common. Yeah, but before that we need to write it in the characteristic equation form. So the characteristic equation will be 2 lambda square minus 5 lambda minus 3 is equal to 0. Okay, 2 lambda square minus 6 lambda plus lambda minus 3 is equal to 0. And from here I can take 2 lambda as common, so it will be lambda minus 3, and I can take plus 1 from here, it will be lambda minus 3. So 2 lambda plus 1 and lambda minus 3 are two factors. So lambda 1 may be taken as minus 1 by 2, and lambda 2 can be taken as 3. So accordingly the general solution will be C1 e power minus lambda 1, so x, so e power minus x by 2, and plus C2 is equal to, C2 e power 3 lambda, 3x, 3 lambda 2 is equal to 3, so 3x. So this will be the general solution. So now consider an initial value problem. Example 3, y double prime plus y prime minus 2y is equal to 0. The initial values are y0 is equal to 4, y prime 0 is equal to minus 5. So it means that the value of the solution function at x is equal to 0 is 4, and value of the derivative of the solution at x is equal to 0 is minus 5. So characteristic equation, instead of lambda you can use any other variable. So maybe some books also use m, so I can use, instead of lambda I can use m. Okay, m square plus m minus 2 is equal to 0. So this I can factorize like this. Okay, plus 3m minus m, plus 2m minus m is plus m, so it should be plus 2 over here. So m square, so m is common, m plus 2 minus 1 into m plus 2 is equal to 0. So it is equal to m plus 2 as common, m minus 1. So in this case the values of m are m1 is equal to minus 2, m2 is equal to plus 1, and the general solution will be C1 e power minus 2x plus c2 e power x. Okay, so now we can, to find the values of c1 and c2, I can input the values of y and x. So from the first condition, y0 is equal to 4, so the value of y is equal to 4. c1, so if e power, that is 0, so it will be c1 plus c2, so both of these e exponential terms will be equal to e power 0. Okay, next condition is, so we have one equation c1 plus c2 is equal to 4. The other condition involves y prime, so we need to differentiate it. So y prime will be equal to minus 2 c1 e power minus 2x and plus c2 e power x. Okay, so y prime was minus 5 is equal to for 0 it will be c1 minus 2 c1 and plus c2. So now we have these two equations, so what I can do is I can bring this equation here, so it will be 4, it will be c1, it will be c2, and then I subtract this equation from the first equation, so it will be minus 9 is equal to, so c2 c2 cancel, so minus 3 c1, so c1 will be equal to 3. So if c1 is equal to 3, so I input this value over here, 4 is equal to 3 plus c2, so c2 will be equal to 1. So now I have the particular solution, so y is equal to c1, which is 3 e power minus 2x plus c2, which is 1 e power x. So this is the solution, specific particular solution. Okay, let's consider another example. So this will be a little bit different from the previous case. Suppose if the equation is y double prime plus 6y plus 9 y is equal to 0, 6y prime plus 9y. So the characteristic equation will be my m square plus 6m plus 9 is equal to 0. So this is a complete square, so m plus 3, so this is actually m plus 3 square, okay, is equal to 0. So m1 is equal to minus 3, m2 will be equal to minus 3. So in this case both roots are equal, so if we say that the solution is c1 e power minus 3x plus c2 e power minus 3x, then that will not be a correct solution, because in this case both these solutions are not linearly independent. So for linearly independent solutions, so the second solution must be different from the first one. Okay, so how do we find that second solution? So in this case, when the roots are equal, distinct, real equal roots, we can prove by the method of reduction of the order that the solution can be given by this equation. So it will be c1 e power minus 3x and plus c2, but this time we will multiply it by x and then e power minus 3x, or alternatively it will be c1 plus c2x into e power minus 3x. This will be the solution. So in this case when the roots are equal, two equal real distinct two equal roots, okay, so then the solution will be given by this formula, and this formula can be easily obtained by the method of the reduction of order, which we tried before. Okay, so so this is the another case. So this was the case 2 earlier. When the roots were different, that was case 1. The next we will consider another case, that will be case 3, where we will have the complex roots.